So a while back I received this printer from a fellow YouTuber, Mr. Keith Rucker, and don't mind the noise in the background because that's actually one of his projects being printed on my freshly modified printer. But I've held off opening this up because I didn't know what I was going to do with this printer, and it kind of dawned on me today that if I was going to do something with this printer, it would need to be something small, something fairly detailed, and I thought, what better thing to do to it than to turn it into possibly a backup for my high precision printer that I just got done making. So, as you can see, it's a fairly small build area on this, and I have no idea what all's in this thing. So, odds are I'm going to have to change a bunch of stuff to make this thing go. Alright, so initial impressions. It is a belt-driven setup, which I will probably be changing. It also has a belt for the Z-axis, which I really don't like. This other one that I'm using right now, it actually has a lead screw for the Z-axis. So I'm probably going to end up modifying that other printer to be set up like this one. And actually I think that's the ultimate goal, is I'm going to buy 3 different lead screws, one for each axis, and then convert the printer over to that, which will probably require some hackery. Alright. Now there's also a box that was in here. I don't know what's in here. Open it up. Okay, so we got a power brick. Let's see what the output is on this thing. 180 watts. 19 volts. Ooh, that's a little hot. So that's going to be a thing. I'll have to figure that one out. Because all the stuff I'm going to be putting in there is 12 volts. Okay, so there's a roll of filament. And let's see what else is in the box. Get this out of the way. Oh, so here's power cord. Looks like a tool for changing the extruder. And some build glass. Okay. That's a nice little surprise. It'll make for some of the next prints. Also looks like it has a Bowden tube of some form. Alright. Alright, well, and the reason I ended up with this printer, I'd helped with a couple projects, and it was offered to me. Apparently, when it is traveling in the Z-axis, it tends to want to drift, and so it basically makes like a leaning Tower of Pisa kind of an effect for everything it does, which doesn't work so well when you want to make straight up and down prints. Let's see, we'll probably pull this ribbon cable off because that's probably not going to get used ever again. Probably pop this off here. Okay. Well, look at that. It's got, on this breakout board, it actually has the regular NEMA type plug for the extruder. So I might be able to actually reuse this extruder cartridge. Yeah, that's good news. I didn't want to have to reinvent this. I'll have to probably extend all these wires out so that they'll reach the new stuff. But I might actually take a look at this board here, because I bet you all the signals I need are in this cable, and I might be able to just more or less reprogram it. So let me plug it back together so I don't forget where everything goes before I get too far here. So it looks like it has a pretty neat little cooling fan slash, okay, look at that. It's got a little bypass duct so you can control whether or not you're doing part cooling, which is fine. I'll probably leave that on, but okay. I'm kind of curious what it has in here for a thread, whether I can use these nozzles or if I got to change them out or if I have to change this block out. Because if I have to change this block out, I'm probably going to change this whole extruder assembly. Just because I like the ones that I've been running on the other printers. Yeah, I might be able to get away with using this stepper though. Just debating whether it'd be worth the effort if I do have to convert this thing. Now we hit our first setback. So on all the other printers that I run, basically it has a threaded tube that goes in between the heater block and the head. This one, I think they were trying to avoid getting heat creep through there, so they, instead of running that threaded tube, they made a little narrowed down tube. But the narrowed down tube extends past the end of the block. And they solved that by counterboring this tip, which is actually threaded the normal M6 that the other ones are. But because of that, the only way I could use a standard nozzle is I'm going to have to bore the nozzle out, which I really don't want to do because that's going to introduce a lot of other problems. So that kind of shoots some of this project in the foot. I'm probably going to have to consider whether or not I'm even going to be able to use this extruder. So I think I'm going to continue just disassembling this extruder and see if there's anything I can salvage out of it. Because if I can't salvage it, then this project might be not economically viable to do. Because once we hit past a certain threshold, I might as well just get a different printer and start from there. I'm already expecting to have to change out all the electronics on this, which is, I happen to have an extra backup set of electronics that I can use on it, but I'd rather not if at all possible. Now, the only good thing so far is these are actually NEMA stepper motors. The little pancake ones, so they don't pull real strong, but they are actually useful and can be converted for other projects as needed. I think in some ways this printer has the same problem that many devices end up having, where it's just straight up over-engineered. My introduction to 3D printers were kits that were DIY, and they were intended to be as cheap to produce as possible using standardized components. So far, the only thing I've seen that's man, look at that. See, you got a support block, you got a fairly complex thing that you have to make. Yeah, this. So we got still a good. There's a good NEMA stepper motor out of this, which can be recycled. And really, I could almost use this stepper on the lead screw printer I just put together, because it is such a the torque requirements on my new printer are a lot lower. so I could get away with a lot less stepper. So I just keep dropping stuff. It is very warm up here in the Pacific Northwest today. Okay, let's get this. And again, with the engineering, where you have to tear apart more than you should need to. We're going to take a second to take a look at this breakout board. Okay, so it's literally just a distribution board. There's no circuits on it. It just has some crossover pathways that are soldered into that. So that's good news. And that's pressed on there, which makes this stepper basically useless. Perfect. Okay, enough bitching about that. Let's get this cover. Ooh, how does this come off of here? Let's take a look at this cover here. Almost looks like this front cover comes off first, which is really inconvenient. Alright, so it's got a little indicator light and power switch. That's all that's attached to that. It's got most definitely a custom PCB, which doesn't do me any good. I was kind of hoping they might have a stepper driver control on this. I'm going to continue tearing this thing, getting these covers off. Now that the front cover's off, I should be able to snake this gantry cover off. I mean, overall, the build quality on this thing is really, really solid. It's just a shame they used the standard component and then turned it into something that you can't repurpose or whatnot. All that does is reduce your serviceability and add cost. On the bright side, the way they put this thing together is actually really good. I mean, they took the time to bundle everything. They took a little pride in their product, and so really, from a build quality standpoint, it's very, very good. I just wish you could actually get parts and replace parts and whatnot. Alright. So that's actually really good. Why does this move so much? Oh, I see. So they actually used the housing as the second linear rail to keep it from wiggling back and forth. It's kind of a neat little belt tensioning system. They got these spring packs on it. And that does not feel smooth at all. What's going on with that? That doesn't make sense why that's not smooth. Yeah, it looks like the gear is pressed on as well. So all the steppers have pressed on gears. Got a couple nice linear rails, but that doesn't really do me any good. It's got a non-standard motherboard, non-standard power supply. steppers I can't change. They did, however, use the geared idler pulley on this other end, which actually makes for a smoother travel. You tend to not get some of the ghosting that you get on one of my printers. Actually, printer number 2, I modified and changed him over to this to help it behave better. I just wonder why this guide rails, it's almost like it's wore out or something, or lost a bearing. This one's so much smoother. That one's really smooth too. Yeah, that's really odd that that one decided to be broken. Well, from what I'm seeing here, I have servos that I can't change the pulleys on. I have guide rails that may or may not be savable. I have a non-standard motherboard, which I kind of thought I might need to replace. I mean, I could probably re-engineer this thing, change out, just use it as is, change out the motherboard to one that I can actually service, but that's going to require me to change the power supply as well. Yeah, I don't foresee this one getting rebuilt, unfortunately. I'm just going to probably end up carefully extracting parts out of it as needed to keep the fleet going. I might be able to get these pulleys pulled off, though it actually looks about like it's the same size drive pulley, or at least very, very close to. No, I guess mine are smaller, so same belt though, so that's good. Yeah, it's a shame because this printer is so stout for what it is. It's, you know, most of the printers I run are very, very flimsy. This one's actually really, really stout. It's well thought out. It's just a shame that they chose to not use more standard components for it, which makes it the end user serviceability down to a minimum. Yeah, we'll just have to. Guess that's it. So.